To start things off here, I'm curious if you could explain what Oumuamua's wager is and what does it mean for humanity and our future?
Oumuamua was the first interstellar object that was spotted near Earth. And by interstellar, I mean an object that came from outside the solar system. We knew that because it moved too fast to be bound to the sun. It's just like finding an object in your backyard from the street. And it saves you the need to go to the street and find out what's going on out there. In particular, from my perspective, it allows us to figure out if the street has neighbors, if we are the smartest kid on the block, because this object looked unusual. It didn't look like any rock that we have seen before in the solar system. It exhibited a very extreme shape because it changed the amount of reflected sunlight by a factor of 10 as it was tumbling every 8 hours. It also didn't have a cometary tail. There was no gas or dust around it. Yet it showed an excess push away from the sun. And the only possible interpretation that came to my mind was a reflection of sunlight. And for that, the object had to be very thin, sort of like a sail, but being pushed by sunlight rather than by the wind, as you often find on a boat. And the nature doesn't make sails. So in a scientific paper, we proposed that maybe it's artificial in origin. And since then, in September 2020, there was another object found that was pushed away from the sun by reflecting sunlight, and without a cometary tail. It was discovered by the same telescope in Hawaii, Pan-STARRS, and was given the name 2020 SO. And then the astronomers realized actually it's a rocket booster that we launched in 1966 in a lunar landing mission. And we know that this object had very thin walls, and that's why it had a lot of area for its mass, and it could be pushed by reflecting sunlight. And we definitely know that it was artificial in origin, and that's why it didn't show a cometary tail, because we produced it. The question is, who produced Oumuamua? And my point is that just like Blaise Pascal, the philosopher, argued that we cannot ignore the question of whether God exists, because Pascal was a mathematician and he said, okay, logically there are two possibilities, either God exists or not. And we can't ignore the possibility that God exists because the implications are huge. And so my argument is very similar. The possibility that Oumuamua is a technological relic carries such great consequences for humanity that we should not ignore it. Many of my colleagues in academia dismiss that possibility. They say we need extraordinary evidence before we even engage in such a discussion. And my point is, requiring extraordinary evidence is in a way of brushing it aside. It's a sort of a self-fulfilling prophecy if you're not funding research that looks for additional evidence. It's sort of like stepping on the grass and claiming the grass doesn't grow, because, for example, to detect gravitational waves required an investment of $1.1 billion by the National Science Foundation. We would never discover gravitational waves unless we invested that amount. To search for dark matter, we invested hundreds of millions of dollars so far. We didn't find what the dark matter is. It's a search in the dark, but without the investment of funds, we will never find. So on the one hand, the scientific community puts almost no funding towards the search for technological relics, and at the same time argues, oh, the evidence is not sufficiently extraordinary for us to consider that possibility in the first place. And I think that's a sign of arrogance. It's a very presumptuous statement to say we are unique and special. There is nothing like us in the universe. I think a much more reasonable, down-to-earth kind of approach is a modest approach, basically saying, look, the conditions on Earth are reproducing in tens of billions of planets within the Milky Way galaxy alone. We know that from the Kepler satellite, about half of the sun-like stars have a planet the size of the Earth, roughly at the same separation. And that means that not only we are not at the center of the universe, like Aristotle argued, we are also, what we find in our backyard is not privileged. There are lots of sun, earth systems out there. And if you arrange for similar circumstances, you might as well get similar outcomes. And actually, most of the stars formed billions of years before the sun. And so that, to me, indicates that there could have been a lot of technological civilization like ours that launched equipment into space, just like we launched the Voyager 1, Voyager 2, New Horizons, and we just need to look for it. Even if these civilizations are dead, you know, we can do space archaeology. And what I mean by that is, you know, when I go to the kitchen and I find an ant, I get alarmed because there must be many more ants out there. So we found Oumuamua. To me, it means that there must be many more out there, and the weird objects that do not look like a comet or an asteroid that we have seen before within the solar system. And we should search for them. For example, in a couple of years, there would be the Vera Rubin Observatory that will be much more sensitive than the Pan-STARRS telescope and could find one such Oumuamua-like object every month. So when we find one that approaches us and we have an alert of a year or so, we can send a spacecraft equipped with a camera that will take a close-up photograph of that object and perhaps even land on it, just like OSIRIS-REx landed on the asteroid Bennu recently and collected a sample from it. Because, you know, they say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book. If we had a photograph, I wouldn't need to write the book. It would be obvious whether it's a rock or an artificial object. And if it is artificial and we land on it, we can read off the label made on planet X and even import the technology that we find there to Earth. And, you know, if it's a technology representing our future, let's say 1 million years into our future, it will save us a lot of time. It will give us a technological leap, and it could be worth a lot of money.
All right, so that's an excellent overview. I think of a really good chunk of the conversation, right? So there's this first part of an interstellar object called Oumuamua entering the solar system in 2017, and then there are lots of parameters about and properties of this object which are not easily or readily explainable as an asteroid or as a comet. Some of these things that we'll discuss are, for example, like its rotation, its brightness variation, its size, its shape, how it was accelerating on its way out. And then, you know, the noticing of this object is happening in a scientific context, which has some sense of arrogance, of not being fully open to exploring hypotheses that seem a bit too weird or too far out there. Like, people are much more comfortable trying to explain it as some kind of like loose aggregate of like a cosmic dust bunny or other things which don't really fit or match the evidence, right? And so then you argue that if we look into this with humility and, you know, epistemic humility, then if we follow the evidence, it takes us to having a reasonable amount of credence that this is actually artificial in origin rather than something natural. And then that brings up questions of other kinds of life and the Drake equation and what it is that we might find in the universe and how to conduct space archaeology. So to start off, I'm curious if you could explain a bit more of these particular properties that Oumuamua had and why it is that a natural origin isn't convincing to you.
Right. I basically followed the evidence. I didn't have any agenda. And in fact, I worked on the universe, the early universe, and the black holes throughout most of my career. And then came along this object and was quite unusual. A decade earlier, I predicted how many rocks from other stars should we expect to find. And that was the first paper predicting that. And we predicted that the Pan-STARRS telescope that discovered Oumuamua will not find anything. And the mere detection of Oumuamua was a surprise by orders of magnitude, I should say. And it is still a surprise, given what we know about the solar system, the number of rocks that the solar system produced. But nevertheless, that was the first unusual fact. But it still allowed for Oumuamua to be a rock. And then it didn't show any cometary tail, and the Spitzer Space Telescope put very tight limits on any carbon-based molecules in its vicinity or any dust particles. And it was definitely clear that it's not a comet, because if you wanted to explain the excess push that it exhibited away from the sun through cometary evaporation, you needed about 10% of the mass of this object to be evaporated. And that's a lot of mass. We would have seen it. The object size is of order the size of a football field, 100 to 200 meters, and we would see such evaporation easily. So that implied that it's not a comet. And then if it's not the rocket effect that is pushing it through evaporation, the question arose as to what actually triggers that push. And the suggestion that we made in the paper is that it's the reflection of sunlight. And for that to be effective, you needed the object to be very thin. The other aspect of the object that was unusual is that as it was tumbling, every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. And that implied that the object has an extreme shape, most likely pancake shape, flat, not cigar shape. The depiction of the object as a cigar was based on the fact that projected on the sky, as it was tumbling, the area that it showed us changed by a factor of 10. So then, of course, if you look at a piece of paper tumbling in the wind and you look at it when it's sideways, it does look like a cigar, but intrinsically it's flat. And that is at the 90% confidence when trying to model the amount of light reflected from it as it was tumbling. The conclusion was at the 90% confidence that it should be pancake shaped, flat, which again is unusual. You don't get such objects very often in the context of rocks. And the most that we have seen before was of the order of a factor of 3 in length versus width. And then came the fact that it originated from a special frame of reference called the local standard of rest, which is sort of like the local parking lot of the Milky Way galaxy. If you think about it, the stars are moving relative to each other in the vicinity of the sun, just like cars moving relative to each other in the center of a town. And then there is a parking lot that you can get to when you average over the motions of all the stars in the vicinity of the sun, and that is called the local standard of rest. And Oumuamua originated at rest in that frame. And that's very unusual because only 1 in 500 stars is so much at rest in that frame as Oumuamua was. So first it tells you it didn't originate from any of the nearby stars, also not likely from any of the faraway stars because they are moving even faster relative to us if they are far away because of the rotation around the center of the Milky Way galaxy. So it was not a natural result to get, a very small likelihood to have an object that is so rare. But it was sort of like a buoy sitting at rest on the surface of the ocean, and the sun bumped into it like a giant ship. And the question is, if it's artificial in origin, why would it originate from that frame? And one possibility is that it's a member of of objects on a grid that serve for navigation purposes. If you want to know your coordinates as you're navigating in interstellar space, you find your location relative to this grid. And obviously you want those objects to be stationary, to be at rest relative to the local frame of the galaxy. And another possibility is that it's a member of relay stations for communication. So to save on the power needed for transmission of signals, you may have relay stations like we have on Earth, and it's one of them. We don't know the purpose of this object because we don't have enough data on it. That's why we need to find more of the same. But my basic point is there were 6 anomalies of this object that I detail in my book, Extraterrestrial, and I also wrote about in Scientific American. And these 6 anomalies make it very unusual. If you assign a probability of 1% to the object having each of these anomalies, when you multiply them, you get a probability of 1 in a trillion that this object is something that we have seen before. So clearly it's very different from what we have seen before. And the response of the scientific community was to dismiss the artificial origin. And then there were some scientists that took the scientific process more seriously and tried to explain the origin of Oumuamua from a natural source. And they suggested 4 possibilities after my paper came out. One of them was maybe it's a hydrogen iceberg, a chunk of frozen hydrogen, that we've never seen before, by the way. And then the idea is that when hydrogen evaporates, you don't see the cometary tail because it's transparent. The problem with that idea is that hydrogen evaporates very easily. So we showed in a follow-up paper that such a chunk of frozen hydrogen, the size of a football field, would not survive the journey through interstellar space from its birth site to the solar system. And then there was another suggestion, maybe it's a nitrogen iceberg that was chipped off the surface of a planet like Pluto. And then we showed in a follow-up paper that, in fact, you need more mass in heavy elements than you find in all the stars in the Milky Way galaxy, by orders of magnitude more, just to have a large enough population of nitrogen icy objects in space to explain the discovery of Oumuamua. And the reason is that there is a very thin layer of nitrogen, solid nitrogen, on the surface of Pluto, and that makes a small fraction of the mass budget of the solar system. And so you just cannot imagine making enough chunks, even if you rip off all the nitrogen on the surface of exoplutos, it just doesn't work out, this scenario. And then there was a suggestion, maybe it's a dust bunny, as you mentioned, a cloud of dust particles very loosely bound, and it needs to be 100 times less dense than air, so that when reflecting sunlight, it will be pushed like a feather. And the problem with that idea is that such a cloud would get heated by hundreds of degrees when it gets close to the sun, and they would not maintain its integrity. So that also has a problem. And the final suggestion was maybe it's a fragment, a shrapnel from a bigger object that passed close to a star. And the problem with that is the chance of passing close to a star is very small. Most objects do not. So why should we see the first interstellar object as belonging to that category? And the second is when you tidally disrupt a big object when passing through near a star, the fragments usually get elongated and not pancake shaped. You get often a cigar shaped object. So all of these suggestions have major flaws. And my argument was simple. If it's nothing like we have seen before, we better leave on the table the possibility that it's artificial, and then take a photograph of future objects that appear as weird as this one.
So you mentioned the local standard of rest, which is the average velocity of our local group. Is that right? Our local group of stars?
Yes. Well, it's the frame that you get to after you average over the motions of all the stars relative to the sun. Yes.
Okay. And so Oumuamua was at the local standard of rest until the sun's gravitation pulled it in. Is that right?
Well, no. So the way to think of it, it was sitting at rest in that frame, and just like a buoy on the surface of the ocean, and then the sun happened to bump into it. The sun simply intercepted it along its path, and as a result, gave it a kick, just like a ship gives a kick to a buoy. The sun acted on it through its gravitational force primarily. And then, in addition, there was this excess push, which was a small fraction of the gravitational force, just a fraction of a percent.
Right, and that's the sun pushing on it through its suspected large surface area, and
Yeah, so in addition to gravity, there was an extra force acting on it, which was a small correction to the force of gravity of the order of a tenth of a percent. And but it was detected at very high significance because we monitored the motion of Oumuamua. And to explain this force, given that there was no cometary evaporation, you needed a thin object. And as I said, there was another thin object discovered in September 2020 called 2020 SO that also exhibited an excess push by reflecting sunlight. So it doesn't mean necessarily that Oumuamua was a light sail. It just means that it had a large area for its mass.
Can you explain why the smooth acceleration of Oumuamua is significant?
Yeah, so what we detected is an excess acceleration away from the sun that declines inversely with distance squared in a smooth fashion. And first of all, the inverse square law is indicative of a force that acts on the surface of the object. And the reflection of sunlight is exactly giving you that. And the fact that it's smooth cannot be easily mimicked by cometary evaporation, because often you have jets. These are spots on the surface of a comet from where the evaporation takes off. And that introduces jitter. As the object tumbles, there is a jitter introduced to its motion because of the localized nature of these jets that are pushing it. You can think of the jets as the jets in a plane that push the airplane forward by ejecting gas backwards. But in the case of a comet, the comet is also tumbling and spinning. And so that introduces some jitter because the jets are exposed to sunlight at different phases of the spin of the object. And moreover, beyond a certain distance, water does not sublimate, does not evaporate anymore. You have water ice on the surface, and beyond a certain distance, it doesn't get heated enough to evaporate. So the push that you get from cometary evaporation has a sharp cutoff beyond a certain distance. And that was not observed in the case of Oumuamua. There was a smooth push that didn't really cut off, didn't show an abrupt change at the distance where water ice would stop evaporating. And so that again is consistent with the reflection of sunlight being the origin of the excess push.
Can you explain the difference between comets and asteroids?
Yeah, so we're talking about the bricks that were left over from the construction project of the solar system. So the way that the planets form is that first you make a star, like the sun, and you make it from a cloud of gas that condenses and collapses under the influence of its self-gravity. Its own gravitational force contracts it, and it cools and makes a star in the middle. But some of the gas has rotation around the center. And so when you make a star like the sun, a small fraction of the gas, of the order of a few percent or so, remains in a leftover disk around the star that was just formed. And that debris of gas in the disk is the birthplace of the planets. And that disk of gas that is left over from the formation process of the sun, of course, includes hydrogen and helium, the main elements from which the sun is made, but also includes heavy elements. And they condense in the midplane of the disk and make dust particles that stick to each other, get bigger and bigger over time, and they make the so-called planetesimals. These are the building blocks, the bricks that come together in making planets like the Earth, or the core of Jupiter that accreted also hydrogen and helium around the central rocky region. So the idea is that you have all these bricks that just like Lego pieces make up the planets, and some of them get scattered during the formation process of the planets, and they remain as rocks. in the outer solar system. So the solar system actually extends 1,000 times farther than the location of the most distant planet, in a region called the Oort cloud that extends to 100,000 times the Earth-Sun separation. And that is a huge volume. It goes halfway to the nearest star. So in fact, if you imagine each star having an Oort cloud of these bricks, these building blocks that were scattered out of the construction process of the planets around the star, then these Oort clouds are touching each other, just like densely packed billiard balls. So just imagine a spherical region of planetesimals, these rocks. And so comets are those rocks that are covered with water ice. So since they're so far away from the sun, the ice freezes, the water freezes on their surface. But some of them have orbits that bring them very close to the sun. So when they get close to the sun, the water ice evaporates and creates a cloud of gas, water vapor, and some dust that was embedded in this rock, that creates this appearance of a cometary tail. So what you see is the object is moving, and then its surface layers get heated up by absorbing sunlight, and the gas and dust evaporate and create this halo around the object and a tail that always points away from the sun because it's calmed by the solar wind, the wind coming from the sun. And so you end up with a cometary tail. That's what a comet is. Now, some rocks were made, remained closer to the sun and are not covered with ice whatsoever. So they're just bare rocks. And when they get close to the sun, there is no ice that evaporates from them. These are called asteroids, and they're just rock without any ice on the surface. And so we see those as well. There is actually a region where asteroids, it's called the main belt of asteroids. We don't know what the origin of that is. It could be a planet that was disintegrated, or it could be a region that didn't quite make a planet and you ended up with fragments floating there. But at any event, there are asteroids, bare rocks without ice on them, because they were close enough to the sun that the ice evaporated and we don't have the water there. And then these objects are also seen in the vicinity of the Earth every now and then. These are called asteroids, and we see basically two populations. Now, Oumuamua was not a comet because we haven't seen a cometary tail around it. And it wasn't an asteroid because there was this excess push. If you have a piece of rock, it will not be pushed much by reflecting sunlight because its area is not big enough relative to its mass. So it gets a push, but it's too small for it to show it, to exhibit it in its trajectory.
Can you also explain how much we know about the composition of Oort clouds and specifically the shape and size of the kinds of objects there, and how Oumuamua relates to our expectation of what exists in the Oort cloud of different stars?
Yeah, so the one thing that I should point up front is when scientists that try to attend to the anomalies of Oumuamua suggest that it's a hydrogen iceberg or a nitrogen iceberg. By the way, that notion gathered popularity in the mainstream. People said, oh, they had a sigh of relief. We can explain this object with something we know. But the truth is, it's not something we know. We've never seen a nitrogen iceberg that was chipped off Pluto in our solar system. The Oort cloud does not have nitrogen icebergs that we witnessed. So claiming that Oumuamua, the first interstellar object, is a nitrogen iceberg or a hydrogen iceberg implies that there are nurseries out there around other stars or in molecular clouds that are completely different than the solar system, in the sense that they produce most of the interstellar objects because Oumuamua was the first one we discovered. So they produce a large fraction of the interstellar objects, yet they are completely different from the solar system. It's just like going, to the hospital and seeing a baby that looks completely different than any child you have seen before at your home, from any child you had. It implies that the birthplace of that child was quite different, but yet that child appears to be the first one you see. So, that's to me an important signal from nature that, you have to rethink what the meaning of this discovery is. And the other message is we will learn something new no matter what. So we need to get more data on the next object that belongs to this family, because even if it's a naturally produced object, it will teach us about environments that produce objects that are quite different from the ones we find in the solar system. And that means that we missed something about nature. And even if it's natural in origin, we learn something really new in the process of gathering this data. So we should not dismiss this object and say business as usual, we don't have to worry about it. Rather, we should attempt to collect as much data as possible on the next weird object that comes along. I should say there was a second interstellar object discovered by an amateur astronomer from Russia called Gennady Borisov, and it was given the name Borisov, discovered in 2019. That one looked just like a comet. And I was asked, does that convince you that Oumuamua was also natural? Because this one looks exactly like the comets we have seen. And I replied, when you go along the beach and most of the time you see rocks and suddenly you see a plastic bottle, and after that you see rocks, the fact that you found rocks afterwards doesn't make the plastic bottle a rock. Each object has to be considered on its own merit, and therefore it makes Oumuamua even more unusual. The fact that we see Borisov as a natural comet. So in terms of the objects that come from the Oort cloud, our own Oort cloud, there is a size distribution. There are objects that are much smaller than Oumuamua and objects that are much bigger. And of course, the bigger objects are more rare. Roughly speaking, there is equal amount of mass per logarithmic size bin. There are many more small objects, and most of them we can't see because Oumuamua was roughly at the limit of our sensitivity with pan-stars, and that means that objects much smaller than the size of a football field cannot be noticed within a distance comparable to the distance to the sun. The sun acts as a lamppost, that illuminates the darkness around us. And so an object is detected when it reflects enough sunlight for us to detect with our telescopes. And so small objects do not reflect enough sunlight and we will notice them. But I calculated that, in fact, if there are probes moving very fast through the solar system, let's say at a fraction of the speed of light that were sent by some alien civilizations, we could detect the emission from them, the infrared emission from them, with the James Webb Space Telescope. They would move very fast across our sky, so we just need to be ready to detect them.
Do you think that given our limited knowledge of Oort clouds, that there are perhaps like exotic objects or rare objects which we haven't encountered yet, but that are natural in origin, that may account for Oumuamua?
Of course, there could be, as I mentioned, the people suggested a hydrogen iceberg, a nitrogen iceberg, a dust bunny. These were suggestions that were already made, and each of them has its own challenges. And it could be something else, of course. And the way to find out, that's the way science operates. The science is guided by evidence, by collecting data. And the way science should be done is you leave all possibilities on the table, and then you collect enough data to rule out all but one interpretation that looks most plausible. And so my argument is we should leave the artificial origin possibility on the table, because all the other possibilities that were contemplated invoke something that we've never seen before. So we cannot argue based on, speculations that it's something that we've never seen before. We cannot argue that proves the point that it's not artificial, right? So it's a very simple point that I'm making, and I'm arguing for collecting more data. I mean, I would be happy to be proven wrong, that it's not artificial in origin, and then move on. The point is that science is not done by having a prejudice, knowing the answer in advance. It's done by collecting data. And, the mistake that was made by the philosophers during Galileo's time is not to look through his telescope and argue that they know that the sun moves around the earth. And that only maintained their ignorance. Reality doesn't care whether we ignore it. The earth continued to move around the sun. If we have neighbors, they exist out there, and it doesn't really matter whether we shut down the curtains on our windows and claim, no, we are unique and special, and there is nobody out there on the street. The fact that we say that, we can get a lot of likes on Twitter saying that, and we can ridicule anyone that argues differently, but that would not change the fact whether we have neighbors or not. That's an empirical fact. And in order for us to improve our knowledge of reality, I'm talking about reality, not about philosophical arguments, just figuring out whether we have neighbors, whether we are the smartest kid on the block. That's within the realm of science. And finding out the answer to this question is not a matter of debate, it's a matter of collecting evidence. But of course, if you are not willing to find wonderful things, you will never discover them. So my point is, we should consider this possibility as real, as very plausible, as mainstream activity, just like the search for dark matter or the search for gravitational waves. We exist. There are many planets out there, just like the Earth. Therefore, we should search for things like us that existed or exist on them. That's a very simple assumption to make and argument to make. And to me, it sounds like this should be a mainstream activity. But then I realized that my colleagues do not agree. And I fail to understand this dismissal, because it's a subject of great interest to the public, and the public funds science. So, if you go back 1,000 years, there were people saying the human body has a soul, and therefore anatomy should be forbidden. So imagine if scientists would say, oh, this is a controversial subject. The human body could have a soul. We don't want to deal with that because some people are claiming that we should not operate the human body. Where would modern medicine be? My argument is, if science has the tool to address a subject of great interest to the public, we have an obligation to address it and clear it up. Let's do it bravely, with open eyes. And by the way, there is an added bonus. If the public cares about it, there will be funding for it. So how is it possible that the scientific community ridicules this subject, brushes it aside, claims we don't want to entertain this unless we have extraordinary evidence, yet fails to fund at a very substantial level the search for that extraordinary evidence? How is that possible in the 21st century?
So given the evidence and data that we do have, what is your credence that Oumuamua is alien in origin?
Well, I have no certainty in that possibility, but I say it's a possibility that should be left on the table with at least as high likelihood as a nitrogen iceberg or a hydrogen iceberg or a dust bunny. That's what I consider as the competing interpretations. I don't consider statements like it's always rocks, it's never aliens as valid scientific statements, because they remind me of the possibility, if you were to present a cell phone to a caveman and the caveman is used to playing with rocks all of his life, the caveman would argue that the cell phone is just a shiny rock. And just basing your assertions on past experience is no different than what the philosophers were arguing. We don't want to look through Galileo's telescope because we know that the sun moves around the earth. So, this mistake was made over and over again throughout human history. I would expect modern scientists to be more open-minded to thinking outside the box, to entertain possibilities that are, straightforward. And what I find is, the strange thing is not so much that there is conservatism, regarding this subject, but at the same time, in theoretical particle physics, you have whole communities of hundreds of people entertaining ideas that have no experimental verification, no experimental test in the foreseeable future whatsoever. Ideas like the string theory landscape, or the multiverse, or some people argue we live in a simulation, or other people talk about supersymmetry. And, awards were given to people doing mathematical gymnastics. And these studies are part of the mainstream. And I ask myself, how is it possible that this is considered part of the mainstream and the search for technological signatures not? And my answer is that these ideas provide a sandbox for people to demonstrate that they're smart, that they're clever. And a lot of the culture in academia is about that. It's not about understanding nature. It's more about showing that you're smart and getting honors and awards. And that's unfortunate because, physics and science is a dialogue with nature. It's a learning experience. We're supposed to listen to nature. And the best way to listen to nature is to look at anomalies, things that do not quite line up with what we expected. And by the way, whether Oumuamua is artificial or not, that doesn't require very fancy math. It's a very simple fact that any person can understand. And who said, nature is under no obligation to reveal its most exciting secrets without fancy math. It doesn't need to be sophisticated. Aristotle had this idea of the spheres surrounding us, that we are at the center of the universe and there are these beautiful spheres around us. That was a very sophisticated idea that many people liked because it flattered their ego to be at the center of the universe. And it also had this very clever arrangement, but it was wrong. So who cares how sophisticated an idea is? Who cares if the math is extremely complicated? Of course, it demonstrates that you're smart if you're able to maneuver through these complicated mathematical gymnastics, but that doesn't mean that it's reflecting reality. And my point is, we better pay attention to anomalies that nature gives us than to promoting our image.
So it seems like there's this interesting, I guess I would say, difference between the extent to which the scientific community is willing to entertain Oumuamua as being artificial in origin, whereas at the same time there's a ton of theories that, at least at the moment, are unfalsifiable. Yet here we have a theory that it is simple, matches the data, and can be falsified.
Right. And the way to falsify it, is not by chasing Oumuamua, because by now it's 1 million times fainter than it was close to the sun. But it's by finding more objects that look as weird as it was. This was the first object we identified. There must be many more. If we found this object by surveying the sky for a few years, we will definitely find more by surveying the sky for a few more years, because of the Copernican principle. The Copernicus discovered that we are not positioned in a special location, in privileged location in the universe. We're not at the center of the universe. And you can extend it also not just to space, but also to time. And when you make an observation over a few years' time, the chance of these few years being special and privileged is small. Most likely it's a typical time, and you would find it if you were to look at the previous 3 years or the following 3 years. And that's the Copernican principle, and I very much subscribe to it, because again, the one thing I learned from practicing astronomy over the decades was a sense of modesty. We are not special, we are not unique. We are not located at the center of the universe. We don't have anything special in our backyard. The Earth-Sun system is very common. So that's the message that nature gives us. And, you know, we are born into the world like actors put on a stage. And first thing we see is the stage is huge. It's 10 to the power 26 times larger than our body. And the second thing we see is that the play has been going on for 13.8 billion years since the Big Bang, and we just arrived at the end of it. So it's certainly, the play is not about us. We are not the main actors. So let's get a sense of modesty, and let's look for other actors that may have been around for longer than we did as a technological civilization. Maybe they have a better sense of what the play is about. So I think it all starts from a sense of modesty. And, you know, my daughters, when they were young, they were at home and they had the impression that they are at the center of the world, that they are the smartest because they haven't met anyone else outside the family. And then when we took them to the kindergarten, they got a better sense of reality by meeting others and realizing that they're not necessarily the smartest kid on the block. And so I think our civilization has yet to mature. And the best way to do that is by meeting others.
I'm curious if you're willing to offer like a specific credence. So you said that there are these other natural theories like the dust bunny and the iceberg theories. You know, if we think of this in terms of Bayesian reasoning, what kind of probability would you assign to the alien hypothesis?
Well, the point is that these objects that were postulated for a natural origin of Oumuamua were never seen before. So there is no way of assigning likelihood to something that we've never seen before. And it needs to be the most common object in interstellar space. So what I would say is that we should approach it without a Bayesian prior. Basically, we should leave all of these possibilities on the table and then get as much data as possible on the next object that shows the same qualities as Oumuamua. And by these qualities, I mean not having a cometary tail, so not being a comet, and showing an excess push away from the sun. And as I mentioned, there was such an object, 2020 SO, but it was produced by us. So we should just look for more objects that come from interstellar space that exhibit these properties and see what the data tells us. It's not a matter of a philosophical debate. That's my point. We just need a close-up photograph and we can easily tell the difference between a rock and an artificial object. And I would argue that anyone on Earth should be convinced when we have such a photograph. So if we can get such a photograph in the next few years, I would be delighted, even if I'm proven wrong, you know, because we will learn something new no matter what.
So there's also been a lot of energy in the news around UFO sightings and UFO reports recently. I'm curious how the current news and status of UFO interest, you know, in the United States and the world, how that affects your credence of Oumuamua being alien in origin, and if you have any perspective or thoughts on UFOs.
Yeah, it's a completely independent set of facts that is underlying the discussion on UFOs. But of course, again, it's the facts, the evidence that we need to pay attention to. I always say, let's keep our eyes on the ball, not on the audience. And because if you look at the audience, the scientists are responding to these UFO reports in exactly the same ways they responded to Oumuamua. They dismiss it, they ridicule it, and that's unfortunate because, you know, the scientists should ask, could we have access to the data? Could we analyze the data? Could we see the full data? Or could we collect new data on these objects so that we can clear up the mystery? I mean, science is about evidence, it's not about prejudice, but instead, the scientists know the answer in advance. They say, oh, these reports are just, you know, related to human-made objects, and that's it. Now, let's follow the logic of Sherlock Holmes. Basically, Sherlock Holmes, as I mentioned in my book, Extraterrestrials, Sherlock Holmes made the statement that you put all possibilities on the table, and then whatever remains after you sort out all the facts must be the truth. That's the way he operated as a detective. So that's the way we should operate as scientists. And what do we know about the latest UFO report from the Pentagon and intelligence agencies? So far, before a few weeks before it's being released, we know from leaks that there is a statement that some of the objects that were identified, that were found, are real. Okay, they are not artifacts of the cameras. They are not illusions of the people who saw them, because they were detected by multiple instruments, including infrared cameras, radar systems, optical cameras, and a lot of people from different angles. And when you consider that statement coming from the Pentagon, you have to take it seriously, because it's just the tip of the iceberg. The data that will be released to the public, presumably, is partial, because they will never release the high quality data because it will inform other nations of the capabilities, the kind of sensors that the US has in monitoring the sky. Okay, so I have no doubt that a lot of data is being hidden for national security reasons, because otherwise it will expose the capabilities of these sensors that are being routinely used to monitor the sky. But if people that had access to the full data, and that includes officials such as former President Barack Obama, former CIA director James Woolsey, and others that saw the data, and they make the case that these objects are real, then these objects may very well be real. Okay, and I take that at face value. Of course, as a scientist, I would like to see the full data, or collect new data. That there is no difference, because science is about reproducibility of results. So if the data is classified, I would much rather place state-of-the-art cameras that you can buy in the commercial sector, and or scientific instrumentation that we can purchase, and just place those in the same locations and record the sky. The sky is not classified. In principle, anyone can collect data about the sky. So I would argue that if the old data is classified, we should collect new data that will be open to the public. And it's not a huge investment of funds to have such an experiment. But the point of the matter is that we can infer if the objects are real. And using the scientific method, then let's assume that they are real, like the people that saw the full data claim. So if they are real, then there are three possibilities. Either they were produced, manufactured by other nations, because we certainly know what we are doing, the US. So if they were produced by other nations, like China or Russia, then humans have the ability to produce such objects, and they cannot exceed the limits of our technologies. And if the maneuvering of these objects looked as if they exceed substantially the limits of the technologies we possess, then we would argue it's not made by humans, because there is no way that a secret about an advanced technology would be preserved on Earth by humans, because it has huge benefits commercially, so it would appear in the market, in the commercial sector, because you can sell it for a lot of money, or it would appear in the battlefield if it's being used by other nations. And we pretty much know what humans are capable of producing, because we are also probably getting intelligence on other nations. So we know what are the limits of human technology. I don't think we can leave that possibility vague. If there is an object behaving in a way that far exceeds what we are able to produce, then that looks quite intriguing. And then the question is that the remaining possibilities are that somehow it's a phenomenon that occurs in the Earth atmosphere. There is something that happens that we didn't identify before, or that these are objects that came from an extraterrestrial origin. Okay, and once again, I make the case that the way to make progress on this is not to appear on Twitter and claim we know the answer in advance and ridicule the other side of the argument. This is not the way by which we make progress, but rather collect better evidence, better clues, and figure it out, clear up the fog. It's not a mystery that should be unraveled by philosophical arguments. It's something that you can measure and get data on and reproduce with future experiments. And once we get that, we will have a clearer view of what it means. And then that's how mysteries get resolved in science. So I would argue for a scientific experiment that will clear up the fog. And the way that we will not do that is if the scientific community would ridicule these reports and the public would speculate about the possible interpretations. That's the worst situation you can be in, because you're basically leaving a subject of great interest to the public unresolved. And that's not the right way, again, in the 21st century, to treat a subject of interest to the public that obviously reaches the Congress. That it's not an eyewitness on the street that says, I saw something unusual. It's military personnel. We have to take it seriously, and we have to get to the bottom of it. So that's the way I look at it. And it may well be that it's not the extraterrestrial in origin, but I think the key is by finding evidence.
So given the age of the universe and the age of our galaxy and the age of our solar system, would you be surprised if there were alien artifacts almost everywhere, or in many places, but we were just really bad at finding them? Or those artifacts were really good at hiding?
No, I wouldn't be surprised, because, as I said, most of the stars formed billions of years before the sun. And if there were technological civilizations around them, many of these stars died by now, and these civilizations may have perished. But if they send equipment, that equipment may operate, especially if it's being operated by artificial intelligence or by things that we haven't invented yet. It may well survive billions of years and get to our environment. Now, one thing you have to realize is when you go in the wilderness, you better be quiet. You better not make a sound and listen, because there may be predators out there. Now, we have not been careful in that sense, because we have been broadcasting radio waves for more than a century. So these radio signals reached 100 light years by now. And if there is another advanced civilization out there with radio telescopes of the type that we possess, they may already know about us. And then if they use chemical rockets to get back to us, it would take them 1 million years to traverse 100 light years. But if they use much faster propulsion, they may be already here. And the question is, are we noticing them? There was this Fermi paradox formulated 70 years ago by Enrico Fermi, a famous physicist, who said, where is everybody? And of course, that's a presumptuous statement, because it assumes that we are sufficiently interesting for them to come and visit us. And, when I met my wife, she had a lot of friends that were waiting for Prince Charming on a white horse to make them a marriage proposal, and that never happened. And then they compromised. And we as a civilization, would be presumptuous in assuming that we are sufficiently interesting for others to have a party in our backyard. But nevertheless, it could be that it already happened, as you said, and we didn't notice. One thing to keep in mind is through geological activity, most of the surface of the Earth gets mixed with the interior of the Earth over 100 million years timescale. So it could be that some of the evidence was buried by the geological activity on Earth, and that's why we don't see it. But the moon, for example, is like a museum because it doesn't have geological activity, and also it doesn't have an atmosphere that would burn up an object that is smaller than the size of a person, like the Earth's atmosphere does for meteors. So in principle, once we establish a sustainable base on the moon, we can regard it as an archaeological site and survey the surface of the moon to look for artifacts that may have landed, may have crashed on it. Maybe we will find a piece of equipment that we never sent, that came from somewhere else, that crashed on the surface of the moon.
It'd be wonderful if we could pivot into great filters and space archaeology here. But before we do that, I'm curious if you're talking about the Fermi paradox and whether or not we're sufficiently interesting to merit the attention of other alien civilizations. I wonder if interesting is really the right criteria, right? Because if advanced civilizations converge on some form of ethics or beneficence, then whether or not we're interesting is not perhaps the right criteria for whether or not they would reach out. Like we have people on Earth who are interested in animal ethics, like how the ants and bees and other animals are doing. So it could be the same case with aliens, right?
Right, I completely agree. One thing I should say, well, actually two things. First, you mentioned before the Drake's equation. It doesn't apply to relics. It doesn't apply to objects. The Drake equation talks about the likelihood of detecting radio signals. And, that has been the method we used over the past 70 years in searching for other civilizations. And I think it's misguided because in order to get a signal, it's just like trying to have a phone conversation. You need the counterpart to be alive. And it's quite possible that most of the civilizations are dead by now. So that's the great filter idea, that there is a narrow window of opportunity for us to communicate with them. But on the other hand, they may have sent equipment into space, and we can search for it through space archaeology and find relics from civilizations that are not around anymore, just like we find relics from cultures that existed on the surface of Earth through archaeological digs. So I think a much more promising approach to find evidence for dead civilizations is looking for objects floating in space. And the calculation of what's the likelihood of finding them is completely different from the Drake equation. It resembles more the calculation of, what's the chance that you will stumble across a plastic bottle on the beach or on the surface of the ocean. And you just need to know how many plastic bottles are per unit area on the surface of the ocean. And then you will know what's the likelihood of crossing one of them. And the same is true for relics in space. You just need to know the number of such objects per unit volume. And then you will figure out what's your chance of bumping into one of them. And that's a completely different calculation than the Drake equation, which talks about receiving radio signals. So, and the other point that I would like to mention is that when during our childhood, we always have a sense of adults looking over our shoulders and making sure that everything goes well. And they often protect us. And then as we become independent and grow up, we encounter reality on our own. And there is this longing for a higher power that overlooks our shoulder. And, that is provided by the idea of God in religion. But interestingly enough, it's also related to the idea of some unidentified flying objects that are looking over our shoulders. Because if a UFO was identified to be of extraterrestrial origin, it may imply that there is an adult wiser than we are in the room looking over our shoulder. The question of whether that adult is trying to protect us is still open, remains open. But we can be optimistic.
Let's talk a little bit about whether or not there might be adults in the room. So you defined what a great filter was. Usually my understanding, so when I think of great filters, I think of there being potentially many of them rather than a single great filter. So there's the birth of the universe, and then you need generations of stars to fuse heavier elements. And then there's the number of planets in Goldilocks zones. And then there's abiogenesis, or the arising of life on Earth. And then there's moving from single to multicellular life. And then there's intelligent life and civilization, et cetera, right? So it seems like there's a lot of different places where there could be great filters. Could you explain your perspective on where you think the most likely great filters might be?
Well, I think it's self-destruction, because I was asked by Harvard alumni, how much longer do I expect our civilization to survive? And I said, when you look at your life and you just select a random day throughout your life, what's the chance that it's the first day after you are born? That probability is tens of thousands of times smaller than the probability that the day you select would be during your adulthood, because there are tens of thousands of days in the life of an adult. So we existed for about a century as an advanced technological civilization. And you ask yourself, okay, well, if we are in our adulthood, which is the most probable state for us to be in, as I mentioned before, you're just sampling randomly a time, and most likely during your adulthood, then that means that we have only a few more centuries left, because the likelihood that we will survive for millions of years is tens of thousands of times smaller. It would imply that we are in the first day of our life, and that is unlikely. Now, the one caveat I have to this statement is that the human spirit can defy all odds. So I believe that in principle, if we get our act together, we can be an outlier in the statistical likelihood function. And that's my hope. I'm an optimist. And I hope that we will get our act together. But if we continue to behave the way we are, not to care so much about the climate, you can even see it in world politics nowadays. Even when you have administrations that care about climate, they cannot really convince the commercial sector to cooperate. And suppose our civilization is on a path to self-destruction, then we don't have more than a few centuries left. So that is a great filter. And of course, there could be many other great filters, but that seems to me as the most serious one. And I would say, that then you ask yourself, okay, so which civilization is more likely to survive? It's probably the dumber civilization that doesn't create the technologies that destroy it. Like if you have a bunch of crocodiles swimming on the surface of a planet, they will not create an atomic weapon. They would not change the climate. So they may survive for billions of years. Who knows? So maybe the most common civilizations are the dumb ones. But one thing to keep in mind is that when you create technological capabilities, you can create equipment that will reproduce itself, like von Neumann machines. or you can send it to space. You can escape from the location that you were born on. And so that opens up a whole range of opportunities in space. And that's why I say that once a civilization ventures into space, then everything is possible. Then you can fill up space with equipment that reproduces itself. And there could be a lot of plastic bottles out there. And we don't know. We shouldn't assume anything. We should just search for them. And the Oumuamua, as far as I'm concerned, was a wake-up call. And the other thing I would like to say is, if I imagine a very advanced civilization, that understands how to unify quantum mechanics with gravity, something we don't possess at the moment. There's such a unification scheme that we know works. Perhaps they know how to irritate the vacuum and create a baby universe that would lead to more civilizations. So it's just like having a baby that can make babies, and you would get many generations as a result of that. So this could be an origin of the Big Bang. Maybe the umbilical cord of the Big Bang started in a laboratory. And by the way, it would say that intelligence, technological advance is an approximation to God, because in the religious stories, God created the universe. We can imagine a technology that would create a baby universe. And then the same is true for life. We don't know if life was seeded, the origins of life was seeded in a laboratory somewhere. And so that remains a possibility. And that's what's so fascinating about the search for intelligent life out there, because it may provide answers to the most fundamental questions we have, like the meaning of life.
Would you consider your argument there about human extinction, given what we are currently observing, is that like the doomsday argument?
Yeah, well, you can call it the doomsday. I would call it risk assessment. And then the question is how. I don't think we are statistical systems in the sense that there is no escape from a particular future, because I think that once we recognize the risk in a particular future, we can respond and avoid it. The only question is whether as a civilization we will be intelligent enough. And frankly, I'm worried that we are not intelligent enough. And it may be just like a Darwinian principle where, if you're not intelligent enough, you will not survive. And we will never be admitted to the club of intelligent civilizations in the Milky Way galaxy unless we change our behavior. And it's yet to be seen whether we will change our behavior accordingly. And one way to convince people to change their behavior is to find evidence for other civilizations that didn't and perished as a result. That would be a warning for us, a history lesson.
So this first point gets into what I understand to be as anthropics. So anthropics is like motivated by the observation selection effect, which says that the kinds of observations that observers can make is limited by the fact that they are observers. So there's this older argument about the universe being finely tuned, but of course, observers are only going to be making observations of universes in which they can be observers, right? And so we're also in the Goldilocks zone of a star. So, observers will only make observations on planets where they can arise. And so then, there's this perspective of taking this line of argument towards existential risk from technology, or for example, the lifespan of the species and where we find ourselves and what that means about human extinction. This really isn't something that I understand very well, but something about anthropics and this doomsday argument, or I think what you call like a risk analysis argument, something that feels really like fishy to me. I'm not sure what it is. It's something about like, every observer is going to make, like, you're going to find yourself at every point in the timeline at like some point in time. So
Right.
I find it difficult to like someone 300,000 years ago could have reasoned the same way. Well, look, 100,000 years ago could have reasoned the same way.
Well, but the difference is that, like animals or we as a civilization 100,000 years ago, we could not change the conditions on our planet. We could not go into space.
Right, but it's just a statistical argument.
But I'm saying we only were able to do that over the past century, and that makes it a very special period. It's a small fraction of the age of the Earth. Now, one caveat I should mention is we always imagine things like us, and when we go to meet someone, it's a fair assumption to assume that that person has eyes and nose and ears the way we have. And the reason it's a reasonable assumption is because we share the same genetic heritage as the person that we are meeting. But if you think about life on a planet that had no causal contact with Earth, it could be very different. And so calculating the likelihood of self-destruction, the likelihood of life of one form versus another, the likelihood of intelligence, all of these very often assume something similar to us, which may not be the case. I think it might be shocking to us to find the creatures from another planet or technologies from another planet. And so my solution to this ambiguity is to be an observer. Even though I'm a theorist, I would argue, let's be modest. Let's not try to predict things in this context. Let's just explore the universe. And the biggest mistake we are making over and over again is to argue about the answer before seeing the evidence. And that's the biggest mistake, because it convinces you to be lazy, not to collect more evidence, to say, I know the answer in advance. I don't need to look through the telescope. I don't need to invest funds in searching for this. Even though it's an important question, I know the answer in advance. And that's the biggest mistake we can make as a species. I'm willing to go through all the hardships of arguing something outside the box, of confronting these personal attacks against me, just because it's a question of such great importance to humanity. If that was a minor question about the nature of dark matter, I would not risk anything for that. Who cares? If the dark matter is axions or weakly interacting massive particles, that has very little impact on our daily lives. It's not worth confronting, the mainstream on that. And by the way, the response would not be so emotional in that case either. But on a subject as important as this one, to the future of humanity, which is the title of your organization, there is no doubt in my mind that it's worth the extra effort, it's worth the hardship, bringing people to recognize that such a search for technological relics in space is extremely important for the way we view ourselves in the big scheme of things, our aspirations for space, our notions about religion, and what we might do in response to the knowledge that we acquire. It will completely change the future of humanity. And on such a question, I'm willing to put my body on the barbed wire.
Thank you very much for putting your body on the barbed wire. I think you mentioned that there was something was it Israeli training where soldiers are taught to put their body on the barbed wire so people can climb over them?
Yeah, that was a statement that in the battlefield, very often a soldier is asked to put his body on the barbed wire so that others can pass through. And the way I see it historically is, you look at Socrates, the ancient Greek philosopher. He advocated for, doubting the wisdom of influential politicians at the time and other important figures. And he was blamed for corrupting the youth by dismissing the gods that were valued by the civilians of the city-state of Athens at the time. And he was prosecuted and forced to drink poison. Now, if Socrates would have lived today, he would have been cancelled on the Athenian social media. That would be the equivalent of poison. And you see another philosopher, Epicurus, that made many true statements, but again was disliked by some religious authorities at the time. And you see, of course, Galileo Galilei, that was put in house arrest. Later on, you see Giordano Bruno. Now, he was an obnoxious person that was not liked by a lot of people, but he simply argued that other stars are just like the sun, and therefore they might have a planet just like the Earth that could have life on it. And the church at the time found it offensive, because if there is life that is intelligent out there, then that life may have sinned, and then Christ should have saved that life. And then you need billions of copies of Christ to be distributed throughout the galaxy to visit all these planets. And that makes little sense. That made little sense to the church. And so they burned Giordano Bruno on a stake. And even though nowadays we know that indeed a lot of stars are like the sun and a lot of planets are just like the Earth at roughly the same separation from their host stars, where life may exist on their surface. So in that sense, he was correct. And obviously you find many such examples also in modern science over the past century, of people advocating for the correct ideas and being dismissed and ridiculed. Just to give you an example, a former chair of the astronomy department at Harvard that preceded me, I chaired the astronomy department for 9 years. I was the longest serving chair in the history of the astronomy department at Harvard. Before me was Cecilia Payne-Kopashkin. And in her PhD thesis, which was the first thesis in astronomy at Harvard, she argued, based on analyzing the spectrum of the sun, that most of the surface of the sun is made of hydrogen. And while defending her PhD thesis, Henry Norris Russell, who was the director of the Princeton University Observatory, an authority on stars at that time, dismissed her idea and said that is ridiculous, because we know that the sun is made of the same elements as the Earth. So, there is not much hydrogen on Earth. It cannot be the case that the sun is made mostly of hydrogen. So she took out that conclusion from her PhD. And then in the subsequent few years, he redid the analysis, got more data, and wrote an extended paper in the Astrophysical Journal arguing the same, that she was correct. And interestingly enough, in a visiting committee to the Princeton University Department of Astrophysics, the chair of that department was bragging that Henry Norris Russell discovered that the sun is made mostly of hydrogen. So you can see that history depends pretty much on who tells it. But the point of the matter is that sometimes when you propose an idea that, even though it has to be correct because it's based on evidence, it's being dismissed by the authorities. And science is not dictated by authority. In the 1930s, there was a book co-authored by tens of scientists arguing that Einstein's theory of relativity must be wrong. And when Einstein was asked about it, he said, "Why do you need tens of scientists to prove that my theory is wrong? It's enough to have one author that would explain why the theory is wrong." Science is not based on authority. It's based on reasoning and on evidence. And there is a lot of bullying going on nowadays, and I witness it. And throughout my career, I've seen a number of ideas that I proposed that were dismissed and ridiculed at first, and then they became the interest of mainstream, and now there are hundreds of people working on them. That was true for my work on the first stars. I remember that it was dismissed early on. There were people claiming even that there are no stars beyond the redshift of 2. And then I worked on imaging black holes. I suggested that there could be a correlation between black hole mass and the characteristic velocity dispersion of stars in the vicinity of those supermassive black holes at the centers of galaxies. I worked on gravitational wave astrophysics long before it was fashionable. And in all of these cases, the interest that I had early on was ridiculed. I gave a lecture in a winter school in 2013, in January 2013, winter school in Jerusalem, on gravitational wave astrophysics. And one of the other lecturers, who still is 20 years younger than I am, stood up and said, why are you wasting the time of these young students on a subject that will not be of importance in their career? And he said that publicly. He stood up in front of everyone. It's on video. And 2 years later, 2.5 years later, the LIGO experiment detected the first gravitational wave signal. Many of these students were still doing their PhD. And this became the hottest frontier in astrophysics in subsequent years. And the Nobel Prize was awarded. So here you have a situation where someone says, why are you giving a lecture on this subject to students? Because it would never be of importance throughout their careers. And 2.5 years later, it becomes the hottest topic, the hottest frontier in astrophysics. And it involves a new messenger other than light that was never used before in astrophysics. Gravitational waves, ripples in space and time. It opens up a whole new window into the universe. So how is it possible that someone that is 20 times younger than I am, stands up, feels that it's completely appropriate for him to stand up in front of all the students and say that? And to me, it illustrates narrow-mindedness. It's not a matter of conservatism. It's a matter of thinking within the box and not allowing to think outside the box. And, that you might say, okay, it's acceptable because there are lots of people suggesting crazy ideas. But at the same time, you have whole communities of theoretical physicists working on very strange ideas that were not verified experimentally. And that is part of the mainstream. And the common thread between these two communities of people is that they both don't pay attention to evidence. They both do not recognize the fact that evidence leads the way. In the case of gravitational waves, it's the fact that we detected the signal. So just wait, for LIGO to find the signal, and then everything will change. In the case of Oumuamua, we saw some anomalies. Let's pay attention to them. Let's talk about them. And in the case of string theory, it's, let's say, this should be at the fringes of mainstream because we haven't found evidence that supports the idea of extra dimensions as of yet. So it doesn't deserve to be center stage. But you have these two communities living side to side because both of them feel comfortable not paying attention to evidence.
We like to think of science as this really clean epistemic process of hypothesis generating and creating theories, and then verification and falsification through evidence and data gathering. But the reality is that it's still made up of lots of humans who have their own need for recognition and meaning and acceptance and validation, right? And so in order to improve the process of science, it's probably helpful to bring light to the reality of the humanity that we all still have when we're engaged in the scientific pursuit, and that helps to open our minds to to the truth, when our pursuit of the truth is not being obscured by things we're not being honest with ourselves about.
Right. And I was the founding director of the Black Hole Initiative at Harvard University, which brings together physicists, mathematicians, astronomers, and philosophers. And my motivation in creating this center was to bring people from different perspectives so that they will open the minds of other disciplines to possible breakthroughs in the context of black holes. And I think this is key. I think we should be open-minded, and we should also fund risky propositions, risky ideas. There should be a certain fraction of the funding that goes in those directions. And, you know, even though I founded this Black Hole Initiative, in the first annual conference that we had, a philosopher gave a lecture, and at the end of the lecture, the philosopher argued that if, after speaking to a lot of string theories, he made the statement that if a bunch of physicists agree on something as being true for a decade, then it must be true. And because physics is what physicists decide to do. And I raised my hand. I said, how can you make so? You know, I would expect philosophers to give us a litmus test of honesty. You know, it's just like the canary in a cave. They should tell us when truth is not being spoken. And I just couldn't understand how a philosopher could make such a statement. I said, there are many examples in history where physicists agreed on something and it was completely wrong. Mm-hmm. And the only way for us to find out is by experimental evidence. Nature is teaching us. It's a learning experience. And, you know, we can all agree that we are the wealthiest people in the world. And if we go to an ATM machine, that's equivalent to doing an experiment and testing that idea. Now we can feel happy until we try to cash the money out of the ATM machine. And then we realize that our ideas were wrong. You know, and how do you tell if someone mentions an idea, how do you tell that whether it's a Ponzi scheme or not? You know, Bernie Madoff told a lot of people that if they give him their money, he will give them more in return, irrespective of what the stock market will do. Now, that was a beautiful idea. It appealed to a lot of people. They gave him their money. What else can you expect from people that believe a beautiful idea? You know, they made money and gave it to Bernie Madoff because the idea was so beautiful. And he felt great about it. They felt great about it. But when they wanted to cash out, which was the experiment, he couldn't provide them the money. So this idea turned out to be wrong. And it's not just the nuance of science to say, oh, okay, there is an experimental test, but you know, we can give up on this as long as we're happy and we feel very smart and we completely agree that we should pursue these questions and just do mathematical gymnastics and give each other awards and feel great about life. And in general, just make the general statement that experiments would be great, but we can't do them right now, and therefore let's not even discuss them. Having a culture of this type is unhealthy for science, because how can you tell the difference between the idea of Bernie Madoff and reality? You can feel very happy until you try to cash it out. And if you don't have an experimental test during your life, then you might spend your life as a physicist on an idea that doesn't really describe reality. And that's a risk that as a physicist, I'm not willing to take. I want to spend my life on ideas that I can test, and if they are wrong, I learn something new. And by the way, Einstein was wrong 3 times in the last decade of his career. He argued that black holes don't exist, gravitational waves don't exist, and quantum mechanics doesn't have spooky action at a distance. But that was part of his work at the frontiers of physics. You can be wrong. There's nothing bad about it. When you explore new territories, you don't always know if you're heading in the right direction. As long as you're doing it with dignity and honesty and integrity, and you are just following what is known at the time, it's part of the scientific pursuit. And that's why people should not ridicule others that think outside the box. As long as they're doing it honestly, and as long as the evidence allows for what they are talking about, that should be considered seriously. And I think it's really important for the health of the scientific endeavor, because we're missing on opportunities to discover new things. Just to give you an example, in 1952, there was an astronomer named Otto Struve that argued that we might find planets close in to a star like the sun if they have the mass of Jupiter, because if they're close in, if they're hot Jupiters, heated by the sun, getting very close to the sun, then they would tug the sun-like star back and forth in a way that we can measure, or they would occult a significant portion of the area of the star so we can see them when they transit the star. So he argued, let's search for those. And for 4 decades, no time on major facilities was allocated for such a search, because astronomers argued, oh, we pretty much understand why Jupiter formed so far away from the sun, and we shouldn't expect hot Jupiters. And then in 1995, a hot Jupiter was discovered, and the Nobel Prize was given for that a couple of years ago. So you might say, okay, that baby was born. Eventually, even though 4 decades were wasted, eventually we found a hot Jupiter. And that opened up the field of exoplanets. But my argument is that this is a baby that was born. For each baby like that, there must be many babies that were never born, because it's still being argued that it's not worth the effort to pursue those frontiers. And that's unfortunate, because we are missing opportunities to discover new things. And if you are not open to discover new things, you will never discover them.
One thing that you mentioned earlier that really caught my attention was you were talking about us becoming technologically advanced, and that would unlock replicators, and that replicators could explore the universe and fundamentally change it and life in our local galactic cluster. That was also tied into the search for the meaning for life. And a place where I see these two ideas as intersecting is in the idea of the cosmic endowment. So the cosmic endowment is this idea of the total amount of matter and energy that an intelligent species has access to after it begins creating replicators. So since the expansion of the universe is accelerating, there's some number of galaxies which exist outside of a volume that we have access to. So there's a limited amount of energy and matter that we can use for whatever the meaning of life is, or whatever good is. So what do you think the cosmic endowment should be used for?
Right. So I actually had an exchange with Freeman Dyson on this question. When the accelerating universe was discovered, I wrote a paper saying, when the universe ages by a factor of 10, we will be surrounded by vacuum beyond our galaxy, and we will not have contact with other civilizations, with resources. And he wrote back to me and said, we should engage in a cosmic engineering project where we propel our star and come together with other civilizations, and by that, we will not be left alone. And I told him, look, this cosmic engineering project is very ambitious. It's not practical. In fact, there are locations where you have much more resources, 1,000 times more than in our Milky Way galaxy. These are called clusters of galaxies. And we can migrate to the center of the nearest cluster of galaxy. And in fact, there might be a lot of journeys taken by advanced civilizations towards clusters of galaxies that would avoid the cosmic expansion. So that's my answer of how to prepare for the cold winter that awaits us, where we will be surrounded by vacuum. It's best to go to the nearest cluster of galaxy where the amount of resources is 1,000 times larger. In addition to that, you can imagine that in the future we will build accelerators that bring particles to energies that far exceed the Large Hadron Collider. And the maximum particle energy that we can imagine is a so-called Planck energy scale. And if you imagine developing our accelerator techniques, you can, in principle, imagine building an accelerator within the solar system that will reach Planck energies. And if you collide particles at these energies, we don't really know the physics of quantum gravity, but you can imagine a situation where you would irritate the vacuum to a level where the vacuum will start burning up. Because we know the vacuum has some mass density, some energy density that is causing the accelerated expansion. It's the so-called cosmological constant. And if you bring the vacuum to a zero energy density state, then you have an excess energy that is just like a burning front. It's the energy you get from a propellant that burns. And you get a domain wall that can expand and consume all the vacuum energy along its path. And of course, it moves at the speed of light. So if you were to be on the path of such a domain wall, you would not get an advance warning, and it will burn up everything along its path at the speed of light. So I think if we ever meet advanced civilizations that have the capabilities of building accelerators that reach the Planck scale, we should sign a treaty, a galactic treaty, whereby we will never collide particles approaching that energy in order not to risk everyone else from domain walls that would burn them up. And that's just a matter of cosmic responsibility.
I think Max Tegmark calls these death bubbles. Is that it?
Yeah, I mean, these are domain walls that, of course, we have no evidence for, but could be triggered by collisions at the Planck scale. And a matter of cosmic responsibility is not to generate these domain walls artificially.
Let's pivot into looking for life and space archaeology, which is a cool term that you've created, and looking for them through biosignatures and techno signatures. One place that I'm curious to start here is, since we were just talking about replicators, why is it that we don't find evidence of replicators or large scale superstructures in other galaxies or in our own galaxy? For example, like a galaxy where half of it has been turned into Dyson spheres. And so, it's like half illuminated.
Right. I mean, presumably such things do not exist. It's actually very difficult to imagine an engineering project that will construct a Dyson sphere. And I think it's much more prudent for an advanced civilization to build small pieces of equipment that go through the vast space in between stars. And that is actually very difficult for us to detect with existing instrumentation. Even a spacecraft as big as a football field would be noticed only when it passes within the Earth's orbit around the sun. That's the only region where pan-stars detected objects the size of Oumuamua from the reflected sunlight. So we will not notice such objects when they are farther than the Earth is from the sun. And the distance to the nearest star is hundreds of thousands of times bigger than that. So most of space is not, it could be filled with things passing through it and that are not visible to us. A spacecraft the size of a football field is huge. We cannot imagine something much bigger than that. And so I would argue that there could be a lot of things floating through space. Also, as of now, our telescopes were not monitoring for objects that move very fast, a fraction of the speed of light. Obviously, if astronomers saw something moving across the sky so fast, they would dismiss it. They would say it makes no sense. We are looking for asteroids or comets that are moving at 1% of the speed of light, 10 to the minus 4 of the speed of light. So so part of it is our inability to consider possibilities that may exist out there, but most of the fact that we haven't yet detected a lot of these objects is a lack of sensitivity. You know, we can't really see these things when they're far away, unless there are major megastructures, as you pointed out. But I think such engineering projects are unlikely.
So I'm curious why you feel that engineering projects like that are unlikely. Like it seems like one of the most interesting things you can do is computation. Computation seems like it has something to do with creating consciousness, and consciousness seems like it is the bedrock of value, given that all value arises in conscious experience. So I would imagine that, you know, using the energy of suns to enable vast amounts of computation is one of the most interesting things that a civilization can do. And the objects that they might send out to other solar systems would be at like a nanoscale, right? You send out like nanoscale replicators. So they'd be even smaller than football fields, or smaller than Oumuamua. And then those would begin, I don't know, Dyson sphere engineering projects, right? And so with artificial superintelligence and billions of years to go in the universe, in some sense, it feels like we're in the early universe. It feels curious to me why superstructures would be unlikely. I'm not sure I totally
because
understand that.
you know, if you think about what a star is just a nuclear reactor that is bound by gravity. Okay, and that doesn't seem to be like the optimal system for us to use. It's better to build an artificial nuclear reactor that is not bound by gravity, like a nuclear engine, nuclear reactor. We're trying to do that. It's not easy to build a fusion reactor on Earth, but we do have a fission reactor. And if I were to think about using nuclear energy, I would say it's much better to use artificially made nuclear engines than to use the energy produced by a giant nuclear reactor that nature produced in particular locations, because then you can carry your engine with you, you are always close to it, you can harness all of its energy, and you don't need to put a huge structure around the star, which you know, brings in a lot of engineering difficulties or challenges. So I would be leaning in the direction of having small systems, a lot of small systems, you know, sent out, rather than a giant system that covers the star. But once again, I would argue that, you know, we should look at the evidence, and there are constraints on Dyson spheres that imply that they're not very common. I should say, a couple of weeks ago, I wrote a paper with an undergraduate student in Stanford, Eliza Tabor, that considers the possibility of detecting artificial lights on the night side of Proxima b, the habitable planet around the nearest star, Proxima Centauri, using the James Webb Space Telescope. And we showed that one can put very interesting limits on the level of artificial illumination on the dark side of that planet, if there are any city lights out there. And the other technological signatures that one can look for are, for example, industrial pollution in the atmosphere of the planet. I wrote a paper about that 6 years ago. You can look for reflectance that indicates photovoltaic cells on the day side of a planet, which is quite different than the reflectance of rock. It has a spectral edge. You can look for light beams that sweep across the sky, that you see them as a flash of light. For example, the light beam used for propulsion using light sails. You know, if you imagine another planetary system where cargoes are being delivered from an Earth-like planet to a Mars-like planet using light sails, the beam of light could cross our line of sight, and we could see it as a flash of light. And we can have even correlate it with the two planets passing along our line of sight. And so that would give us confidence that indeed it's a light sail traveling between those two planets that we are witnessing. So there are all kinds, and I wrote a paper about that in 2016. So there are all kinds of technological signatures we can search for, but we need to search for it, and we need to put funds towards this search.
Right. So we have both biosignatures and technosignatures. In terms of biosignatures, there is you've proposed looking in the clouds of brown dwarfs and green dwarfs. There's looking around our own solar system through looking at the elements in, for example, the atmosphere of Venus. There was phosphine, which we thought could not exist except through biological pathways. And so it's hypothesized that maybe there's some kind of life in the atmosphere of Venus. They're searching for other searching other planets for elements that can't exist without life. And then in terms of technosignatures, right, they're searching for radio waves, which you've talked about, SETI, as SETI's primary way of looking for life, but it potentially needing a refresh, where it is, for example, looking for artificial light or the remnants of industry. And you've also proposed the increasing the threshold of sensitivities for developing imaging that is increasingly sensitive, right? Because Oumuamua was at the limit of our telescope's capacity?
It was roughly, I mean, it was at the level of sensitivity that allows us definite detection, but we can't see objects that are much smaller than that or reflect much less light than Oumuamua did. Yeah, so I should say that all of these, both biological signatures and technological signatures, are being reviewed in a new textbook that I wrote together with my former postdoc, Manasvi Lingam, that is coming out to be published on the 29th of June, 2021. It's more than 1,000 pages long. It's 1,061 pages long, and it has an overview of the current scientific knowledge we have and expectations we have for biological signatures and technological signatures. The title of the book is Life in the Cosmos, and it's to be published by Harvard University Press. It is meant to be a textbook for scientific research as a follow-up on my popular level book, Extraterrestrial. Right. If you just put in Life in the Cosmos, Harvard University Press, you'll get to the webpage. It's also on Amazon already for sale because it will come out in 2 weeks.
So pivoting a bit here, do you feel that, we mentioned this a little bit earlier when we were talking about the difference between aliens being interested in us or compelled to reach out to us because of ethical concerns. Do you think that advanced alien civilizations can converge on ethics and beneficence?
And that's an interesting question. It really depends on their value system, and it also depends on Darwinian selection. The question is, what kind of civilizations will be most abundant? If you look at human history, very often the more aggressive, less ethical cultures survived because they were able to destroy the others. So it's not just a matter of which values appear to be more noble, it's the question of which set of values leads to survival in the long run and domination in the long run. And without knowing the full spectrum of possibilities, we can't really assess that. So once again, I would say the smart thing for us to do is be careful. I mean, not transmit too much to the outside world until we figure out if we have neighbors. You know, there was this joke when I Love Lucy was replayed again and again that we might get a message from another planet saying, if you keep replaying reruns of I Love Lucy, we will invade you. I think it's important for us to be careful and figure out first whether there are smarter kids on the block. But having said that, if we ever establish contact or if you find equipment, in our neighborhood. The question is what to do. How, it's a policy question, how to respond to that. And it really depends on the nature of what we find. You know, how much more advanced is the equipment that we uncover? What were the intentions of those who produced it and sent it? These are fundamental questions that will guide our policy and our behavior. And until we find conclusive evidence, you know, we should wait until that moment.
So to push back a little bit on the Darwinian argument, right? That's of course a factor where we have this kind of game theoretic expression of genes, the selfish gene trying to propagate itself through generations, and that leading to behaviors and you know how the human being is conditioned by evolution in that way. There's also the sense that over time humanity has become increasingly moral. We're of course doing plenty of things right now that are wrong, but morality seems to be improving over time. And so this leads to a question where, for example, do you think that there is a relationship, a necessary relationship between what is true and what is good? So, for example, if an intelligent species was, you need to know more and more true facts in order to, for example, spread throughout the universe. And so, if there's a necessary relationship between what is true and what is good, then there would be a convergence then also on what is good as truth continues to progress.
Yeah, I was asked in a forum when I joked about the fact that I'm seeking intelligence in space, in the sky, because I don't find it often here on Earth. A member of the audience chuckled and asked me, how do you define an intelligent civilization? And the way I define it is by the guiding principles of science, which is sharing or cooperation on evidence-based knowledge. Okay, and the word cooperation is extremely important. I believe that intelligence is marked by cooperation, not by fighting each other, because that's a sink for our energy, for our resources, that doesn't do any good. So promoting a better future for ourselves through cooperation is a trademark of intelligence. It's also the guiding principle of science. The second component of these guiding principles is evidence-based knowledge. And the way I view science is as an infinite sum game. You know, in economics, you have a zero-sum game where if someone makes a profit, another person loses. In science, when we increase the level of knowledge we have, everyone benefits. When a vaccine was developed for COVID-19, everyone on Earth benefited from it. And so science aims to increase the territory of this island of knowledge that we have in the ocean of ignorance that surrounds it. And it should be evidence-based, not based on our prejudice. So that's what I hope the future of humanity is. It will be coincident with the guiding principles of science, meaning people will cooperate with each other, nations will cooperate with each other, and try to share evidence-based knowledge. Rather than, what's the alternative? The alternative is what we are doing right now, fighting each other, trying to feel superior relative to each other. If you look at human history, you know, you find racism, you find attempts to feel supremacy or elitism, or you know, all kinds of phenomena that stem from a desire to feel superior relative to other people. And that's ridiculous in the big scheme of things, because, you know, we are such an unimportant player in the cosmic stage that we should all feel modest, not try to feel superior relative to each other, because any advantage that we have relative to each other is really minuscule in the big scheme of things. You know, the color of the skin is completely meaningless. Who cares what the color of the skin is? Like, what significance could that have for the qualities of a person? And yet, a lot of human history is shaped around that, or you know, and this is not the intelligent way for us to behave as a species. We should focus on the guiding principles of science, which are cooperation and sharing of evidence-based knowledge, rather than ridiculing each other, rather than trying to feel superior relative to each other, rather than fighting each other. Let's work together towards a better future and demonstrate that we are intelligent, so that we will acquire a place in the club of intelligent species in the Milky Way galaxy.
Do you see morality as evidence-based knowledge?
I think morality, if you listen to Kant, it's the logical thing to do if you consider a principle such that it will promote the better good of everyone around you. You're basically taking into consideration others and shaping your behavior so that if other people follow the same principles, we will be in a better world. Okay, and that to me is a sign of recognizing evidence, because the evidence is that you don't live alone. If you are to live alone, if you are the only person on earth, morality loses significance. Not only that there is nobody else for you to consider morality relative to, that's not the issue. The issue is that it's irrelevant. You don't need to consider morality because you're the only person. So you can do whatever you want, like it has no effect on other people, therefore morality is not relevant. You can do whatever you want. But given the fact that you look at the evidence and you realize that you're not alone, that's evidence. You shape your behavior based on that evidence. And I do think that's evidence-based knowledge, definitely.
How do you see axiomatic based knowledge? So for example, like axioms of morality in mathematics that build these structures. They're also axioms, for example, of science, like this value of communication and evidence-based reasoning. And axioms in morality are, for example, might be that I don't know, like consciousness is like value and disvalue are innate and intrinsically experienced in consciousness. And then there are axioms in mathematics which motivate and structure that field. So how do you, so we've talked a lot about science and evidence-based reasoning, but what about knowledge that in the philosophical territory, which is almost like a priori true, like things which we rest fields upon? How do you see that?
Yeah, I do believe that there is room for humanities of the future. The way that philosophy was handled in past centuries should be updated. And let me illustrate that with an example related to your question. Basically, suppose we want to decide about the principles of morality. The way to do that is you can construct a simulation that includes a lot of people. So in principle, if you include all the ingredients that make people behave one way or another, it doesn't need to be rational reasoning. You can include some randomness or some other elements that shape human behavior based on their environment. You can include that in the simulation. So let's just imagine a simulation where you put individual people, and the way you have an algorithm for the way that they respond to their environment. Doesn't need to be by rational reasoning. It could be emotional. It could be any other way that you find appropriate. And you put that, you have the building blocks. Each of them is a person, and you introduce the randomness that is in the population. And then you run the simulation and you see what happens. Okay. So this is just like trying to produce human history artificially. And then you introduce principles for the behavior of people. Guiding principles, just like moral principles. So first you let people behave in a completely crazy way, like anything they want, and you will get chaos as the outcome of this simulation. But if you introduce principles of morality, you can see the outcomes that will come out of it. So what I would say is, in principle, in the future, if we have a sophisticated enough computer algorithm to describe behavior of people based on our understanding of how people behave. If we get a better sense of how people behave and respond to their environment, we can design the optimal code by which people should behave such that we will end up in a stable society that is intelligent, that follows the kind of principles I mentioned before, that is orderly, and that benefits everyone for a better future. And that's one way of approaching it. And obviously, in the past, philosophers could not approach it this way because they didn't have the computer capabilities that we currently have. You can imagine artificial intelligence addressing this task in principle.
Right. So you can set moral principles and moral parameters for a system and then evolve the system, right? But there's criteria for evaluating the success or not of that system, and those are more like moral axioms. So as a scientist, I'm curious about how you approach, for example, moral axioms that you use for evaluating the evolution of a particular moral system.
So my criterion, the one that I think that guides me, is maintaining the longevity of the human species. So whatever will keep us for the longest amount of time, of course, bearing in mind that the physical conditions will change on Earth. So within 1 billion years, the sun will boil off all the oceans on Earth. But let's leave that aside. Let's just ask, suppose you put people in a box and let them, generation after generation, let them follow some principles. What would be the ideal principles to maintain the stability of society and the longevity of the human species? That's what will guide me. Okay, I think survival is really the key for maintaining your ideas. That's the precondition, right? So in nature, things that are transient, they go away, they don't survive, and they lose their value. So they have less value. I mean, obviously, in the short term, they could have more value, but I care about the long term. And I define the principles based on how long they would allow us to survive.
Would you add expected value to that calculation? So it's not just time, but it's actually like the expected reward or expected value over time, right? Because some futures are worse than others. And so maybe we wouldn't want to just have longevity.
Yeah, there is the issue of being happy and pleased with the environment that you live in. That could be factored in. But I think the primary principle would be survival, because within any population, you always will find a fraction of the components that are happy. And it partly depends on the circumstances that they live in, but partly on the way they accept those circumstances. You can live in a barrel and be happy. You can be in a mansion and be unhappy. So it's complicated as to what makes you happy, and I would put that as a secondary condition. I would worry more about social structures that maintain longevity.
On humanity's longevity, we're basically beginning to become technologically advanced. We're facing existential risks in the 21st century from artificial intelligence and nuclear weapons and synthetic biology. And there's UFOs and there's Oumuamua and a lot of really interesting, crazy things are going on. So I'm curious if you could touch on the challenge of humanity's response and the need for international governance for potentially communicating and encountering alien life.
Well, I do think it's extremely important for us to recognize that we belong to the same species. So all the confrontations we often have in politics, between nations, they should play a lesser role in guiding our behavior. Cooperation on the global scale, international cooperation, is extremely important. And let me give an example from recent history. There was a virus that came from Wuhan, China. And if scientists were allowed to gather all the information of how this virus came and what the characteristics of this virus are, then the vaccine would have been developed earlier and it could have saved the lives of many people. So I would say in the global world that we live in today, many of our problems are global, and therefore we should cooperate on the solutions. And that argues against, putting borders in our knowledge, trying again to gain superiority of one nation relative to another, but instead help each other and towards a better future. And it's really the science that provides the glue that can bind us internationally. And I realize, I'm trying to be realist, that it may not happen anytime soon, that people recognize the value of science as the international glue. But I hope that eventually we will realize that this is the only path that will bring us to survival, to a better future, if we act based on cooperation, on evidence-based knowledge.
In 2020, you have an article where you advocate for creating an elite scientific body to advise on global catastrophes. As the Future of Life Institute, we're interested in reducing the risks of existential risks. So ways in which technology can be misused or, lead to accidents which lead to the extinction of life on Earth. Could you comment on your perspective on the need for an elite scientific body to advise on existential risk and global catastrophic risk?
Well, we noticed that during the pandemic, we were not really prepared, especially in the Western world, because the last big major pandemic of this magnitude took place a century ago, and nobody around today in politics or otherwise was around back then. And as a result, we were not ready, we were not prepared. And I think it's prudent to have an organization that will cultivate cooperation globally. And it could be established by the United Nations, it could be a different body, but once again, it's important for us to plan ahead and avoid catastrophes that could be more damaging than COVID-19. And if you prevent them, it would more than overpay for the investment of funds. Just to give you another example, solar eruptions, solar storms. If there was a Carrington event about 150 years ago, it was a big eruption on the sun that brought energetic particles to Earth. And back in the mid 19th century, there wasn't much technological infrastructure. But if the same event would have happened today, it would cost trillions of dollars to the world economy, because it would damage power grids and satellites, communication, and so forth. And it would be extremely expensive. So it's important for us to plan ahead. There was, about 7 years ago, there was a plume of hot gas that was ejected by the sun, and it just missed the Earth. And we should be ready for that and build infrastructure that would protect us for such a catastrophe. And there are many more. So one can go through the risks, and some of them are bigger than others, some of them are rarer than others. Of course, one of them is the risk from an asteroid hitting the Earth, and the Congress tasked NASA to find all asteroids, all rocks bigger than the size of Oumuamua, about 140 meters. They wanted the NASA to find 90% of all of those that could potentially intercept the Earth and collide with Earth. And the Pan-STARRS telescope that we started from, that discovered Oumuamua, was funded for finding such near-Earth objects. And the Vera Rubin Observatory will most likely fulfill 2/3 of the congressional task and find 60% of all the near-Earth asteroids bigger than 140 meters. That shows that the human brain is actually much more useful for survival than the body of a dinosaur, because the dinosaurs had huge bodies And 66 million years ago, they were very proud of themselves. They dominated their environment. They ate grass and were happy. And then from the sky came this giant rock the size of Manhattan Island. And when it hit the ground, it tarnished their ego trip abruptly. And so just to show you that the human brain, even though it's much smaller than the dinosaur body, is much more precious for protecting us, because we can design telescopes that would alert us to incoming objects. And that's a catastrophe that obviously we can protect ourselves against by shifting the trajectories of objects heading our way.
As a final question, I'm curious, what are the most fundamental questions to you in life, and what motivates and excites you from moment to moment as a human being on Earth? I've read or heard that you were really interested in existentialism as a kid. So yeah, what are the most foundational or important questions to you?
Well, the fundamental issue is that we live for a finite time, with short time, and so the question is, what's the meaning of our existence? You see, because very often we forget that this trip that is very exciting that we're having and could be very stimulating and intriguing is finite. And when I realized that, when both my parents passed away over the past 3 years, I came to the realization that I don't give a damn on what other people think. Let's focus on the substance. Let's keep our eyes on the ball, not on the audience. And it was the focusing of my attention to the important things in life that we should appreciate. And then there is this fundamental question of, why is life worth living? What are we living life for? And what is the meaning of our life? And that's it may well be that there is no meaning, that we just go through this interesting trip. We are spectators of the universe, and we should enjoy the play while it lasts. But that again argues that we should be modest and behave like spectators, rather than trying to shape our immediate environment and feel a sense of deep arrogance as a result of that. That was the view of the dinosaurs before the rock hit them. So in a way, what gives me a sense of meaning for life is just looking at the universe and learning from it. That I don't really care about my colleagues. Every morning I jog at 5 a.m. I developed this routine during the pandemic, and I enjoy the company of birds, ducks, wild turkeys, and rabbits. And I really enjoy nature left to its own much more than people, because there is something true in looking at me. Every morning I see something different. Today I saw a red bird. I saw the sunrise was completely different than yesterday. So every day you can learn new things, and you just need to pay attention, not to feel that you know everything. It's not about us. It's about what is going on around us that we should pay attention to. And once we behave more like kids, appreciating things around us and learning from them, then we would feel happier. And I was asked by the Harvard Gazette, what is the one thing I would like to change about the world? And I said, I would like my colleagues to behave more like kids, basically not being driven by promoting their image, but rather, willing to make mistakes, putting skin in the game, and learning, regarding life as a learning experience. We might be wrong sometimes, but we are doing our best to figure out when we are wrong.
All right, Avi, thank you very much for inspiring this childlike curiosity in science, for also helping to improve the cultural and epistemic situation in science, and also for your work on Oumuamua and everything to do with extraterrestrials and astronomy. So thank you very much for coming on the podcast.
Thanks for having me. I had a great time.